If the Earth lost its oxygen for exactly 5 seconds, you might think you know exactly what would happen. The average person can hold their breath for about 30 seconds. Experiencing a sudden 5-second pause in your air supply seems like a completely harmless event. This chart shows the composition of the atmosphere around us. Oxygen makes up 21% of the total volume of the air. Removing that specific volume instantly creates a massive vacuum. The surrounding atmosphere collapses inward, causing a drastic, violent drop in air pressure. That sudden change in pressure is the physical equivalent of teleporting from sea level to an altitude of 2,000 meters in a fraction of a second. Human biology requires a gradual transition to handle pressure differentials. Experiencing that extreme shift instantaneously would cause your inner ears to rupture. Forget about holding your breath. Long before your brain even registers the urge to gasp for air, you would be completely incapacitated by severe barotrauma. At the exact same moment, the daytime sky turns pitch black. Without oxygen particles in the upper atmosphere to scatter sunlight, the blue sky vanishes completely. The ozone layer above us is made entirely of molecular oxygen. Stripping it away removes our shield against ultraviolet radiation, guaranteeing severe, instant sunburns for anyone caught outside. Down on the ground, the internal combustion process completely halts. Every gas-powered car, truck, and generator on the planet stalls simultaneously. Commercial airplanes would lose their engines, but they wouldn't drop from the sky like stones. Large aircraft generate forward lift and can glide for miles without thrust, much like the famous emergency landing on the Hudson River. Those are the immediate mechanical and biological effects of losing molecular oxygen gas. That is actually the optimistic scenario. The thought experiment usually ignores the catastrophic reality of what happens if we extract the oxygen atom itself. Oxygen is an invisible gas in the air, but it also acts as a primary chemical binding agent for solid materials on Earth. Concrete relies on carbon dioxide-based compounds to maintain its physical rigidity. Extract the oxygen atoms from those compounds, and the chemical bonds fail. Massive structures built into the landscape, like the Hoover Dam, would immediately lose their structural integrity. Within a second, millions of tons of reinforced concrete would disintegrate into a cloud of fine, dry powder midair. Metals would experience an equally destructive failure. Two pieces of untreated metal don't permanently fuse together when they touch on Earth because they are coated in an invisible protective layer of oxidation. In a vacuum environment completely devoid of atomic oxygen, clean metals undergo a process called cold welding. They instantly spot weld to one another upon physical contact. We have seen this happen in real life. In 1989, NASA's Galileo spacecraft failed to properly deploy its high-gain antenna because the metal ribs rubbed together in the vacuum of space and permanently cold welded shut. Human civilization relies entirely on the oxygen atom to act as an invisible barrier between metals, and as the chemical glue holding our physical infrastructure together. The destruction scales up significantly when you look at the planet itself. By mass, 45% of the Earth's crust is made of oxygen. Extracting that atomic material means the solid ground beneath our feet would fracture and crumble, dropping anything on the surface into a chaotic freefall. Then, the chain reaction reaches the largest reservoir of atomic oxygen on the planet, the world's oceans. Water is 2 parts hydrogen and 1 part oxygen. Severing the chemical bond between those atoms requires a staggering amount of physical energy. This chart shows the enthalpy scale, the total heat content of a system. The first bar represents the energy required to bring water to a boil, which is roughly 4 kilojoules per mole. Forcibly breaking the oxygen-hydrogen bond creates a completely different energy reaction. The release spikes to 463 kilojoules per mole. Multiplying that massive energy release across the entire volume of the Earth's oceans creates a thermal chain reaction with the destructive potential of a planetary-scale bomb. Stripping the oxygen out of the oceans leaves behind pure hydrogen gas, which is lighter than air and evaporates upward immediately. Severing those chemical bonds across 70% of the Earth's surface releases all that thermal energy at once, causing the planet to detonate. From a distance, the Earth would erupt into a blinding, expanding sphere of intense white light, glowing temporarily with the intensity of a small star. Losing the oxygen atom triggers a localized Big Bang that permanently vaporizes the Earth. Fortunately, the chemical bonds holding our planet together remain deeply stable, and this cataclysmic sequence is physically impossible. The thought experiment serves a different purpose. It highlights the vast difference between losing the air we breathe and losing the elemental building blocks of matter. We experience oxygen as the invisible gas inflating our lungs. In reality, it serves as the architectural, physical, and chemical glue holding the fabric of our physical reality together.